Hello everyone, hope for your well-being. Let's continue the discussion. And for JEE Mains 2021, August 26 morning paper, concept explanation with solution by sapienseducation.com. Next. The next question says that what equal length of an iron wire and a copper nickel alloy wire, each of diameter this, connected in parallel to give an equivalent resistance of E. That means the question itself is simple but lengthy because R equivalent is given you as 3 ohm and you are connecting them in parallel. So this will be R1 R2 by R1 plus R2. So let's take the first one, that will be an iron wire. So in case of iron, so R1 will be equals to rho. So rho is different for them. So rho 1 length we are taking equal rho L by A. Area is for this is A1 and the area is given as C. So this will be the result. 12 by A will be the resistance. And same case if I will take the case of copper nickel wire. So copper nickel wire. In that case also you should say that R2 is equals to rho 2 L by A. Let's substitute all these values. So R1 is equals to, if I will multiply them, so this will become rho 1 rho 2 and this will become L square by A square, and one side it will be cancel also, so this will become L by A divided by R1 plus R2 will give you rho 1 plus rho 2. So basically the we can say that 3 times of rho 1 plus rho 2 by rho 1 rho 2 into area will be equals to L. So let's calculate the value. 3 into rho 1 plus rho 2 by rho 1 into rho 2 we have to calculate. So rho 1 plus rho 2 is 12 plus 51, that is 63 divided by 12 into 51, and there micro 1 will be left, so it will become 10 to the power minus 6 into the area will be for this is pi by 4 r square, so this will be pi, diameter is given, so pi by 4 diameter square, so diameter is 2 mm square, that will give you 2 mm is 4 and mm square is 10 to the power minus 6. So this 10 to the power minus 6 cancel. This is 4 is 4 is cancelled. 12 will equals to 3 pi into 61 divided by 12 into 51. So 3 100 3 3 7 21, and you can give here also 3 21 3 4 12. So 21 pi by 68 is the roughly answer. So this will be equals to 21 into pi. Pi will be roughly equals to 3.14 and divided by 68. And you can also use 22 by 7 because it will be easy and convenient to cancel it out. So this will become 22 by 7 into 68. So 7 3s are 21. So the answer will be 66 divided by 68. So the answer will be 33 by 34. Extremely closer to 1 meter, so that the answer is 100 meter, that should the answer will be 97 meter. So this will be the answer for the next question. Let's move to the next question. You should take care that the answer will be 97 meter because there it is a centimeter, so you should have to convert there also. So that part is make it 100 in multiplication. Okay? So the conversion of units. So next question. Let's move to the next question. It's given you that the initial mass of a rocket. So let's try to understand basic principle behind rocket propulsion. So the basic principle behind rocket propulsion is, let's take this as a rocket. So what will happen as the fuel will be burned, the gas will be released and gas will go to the ground and exert force on the ground. The equal and opposite force will be exerted by the ground on the rocket, and that is called as the thrust force. The thrust force is the force exerted by ground on the rocket. So this will be equals to V dm by dt. Mathematically, if this thrust force is greater than mg, then the rocket will move up. If thrust force will be less than mg, then the rocket will not move up. So this is the first one. Now, if the rocket is moving up, then the thrust force is responsible to make it move. So thrust force will take it up, and mg will try to oppose it. So the equation will become the thrust minus mg should be equals to ma, and the basic equation for rocket propulsion is m into g plus a, where this can be written as v dm by dt is equals to mg plus a, there where this will be v will be the relative velocity of exhaust gases, because the velocity of gases is responsible for the thrust force, because the gases will go and exert equal and opposing force on the ground will exert equal and opposing forces on the earth. Now we have to see the various parameters you already know. The initial mass is 1000 kg. Calculate at which rate the fuel is burned. So you have to calculate dm by dt, the rate of burning of fuel you have to calculate. In a rocket, given an acceleration is 20, so the acceleration itself is 20 plus this is g is 10, and the gases come out at a relative speed. So the speed is also given here, and they are not saying about the time. So the everything is given for that instant only, and we have to take the complete mass, although we should know at what instant we are calculating, because the mass of rocket will decrease by the same rate. So let's take this as an initial scenario. So this will be m will be 1000 is equals to relative velocity is 500 and dm by dt. So dm by dt will actually be equals to 30 into 2 is 60 kg per second. This will be the answer. 60 kg per second will be the answer. Important point again, see that this is related to initial state. It's given that we should have to write this is also an initial acceleration, not the last one. The next question. The following quantities are given with this. What's the dimension of P? Where so we have to calculate the dimension of P is equals to EL square m की power minus 5 g की power minus 2. We are dealing with this. Here E represents energy, where E represents energy and L represents angular momentum, while M is a mass and G is a gravitational constant. So let's take the dimension of energy is ml2t minus 2. Angular momentum dimension is mvr, so m velocity is lt minus 1 and r is again l, so ml2t minus 1. Again it's divided by m की power minus 5, m minus 5, and the gravitational constant dimension is ml minus 1, L3 t minus 2 to power minus 2. Let's calculate all of them. So m total kitna? So 1 is here, another one minus 5, and this is minus 2 into minus 2 is plus 2. While in L case it will be 2 plus 2. Here there is nothing there, so it will be minus 6. 3 into minus 2 is minus 6. In case of t, the power will finally become minus 2 minus 1, and this will become minus 1 is plus 2 into 2 is 4. So this will be the values. So m will yield out to be minus 1 and L will yield out to be minus 2. This is L square. So this will become 2, this will become 4, and this will become minus 2. So this will yield out to be 2 plus 4 is 0, and this will yield out to be 0, and t raised to the power 0, this will yield out to be. So the answer is m0, L0, t0 will be the final answer. The next one, the material inside the plates of a parallel plate capacitor. So there's a parallel plate capacitor, and there's a material inside it has a resistivity of a certain amount of resistivity is given. Resistivity is given you as 200 ohm meter. The value of capacitance, and the capacitance is given you as 2 picofarad. If the potential difference, we have already applied it a potential difference of 40 volt across the capacitor. Find the value of leakage current through the capacitor. So we have to calculate the value of leakage current through the capacitor. Now the concept of leakage current. Generally in NCERT we don't take the leakage current concept, but here we have to understand the leakage current concept. So what will happen is, because generally we assume it's a perfect dielectrics and they have a perfect dielectric constant as given for a material is dielectric constant is given as 50. So there will be no flow of charges or the current through this. But here the problem is it has certain amount of resistivity, and in theoretical experiment theoretically we are assuming it has infinite resistivity. So infinite resistivity means it will not allow a single charge carrier that will be on this side, positive side, to go in this side, that's a negative side. But there will be a small amount of charge that will be leaked through this material, and this leakage we have to calculate. So basically we have to calculate the leakage. I mean the amount of charges that will flow through this conductor. So I have to calculate the current. But current can also be given as J dot dA. J is a current density. So we are driving the result. So I will be equals to, but in case of metal, because it is behaving like a conductor, in that case the current density is given as sigma into E, where sigma is a conductivity into dA. So the current will be equals to sigma, and this will be E. Electric field is uniform throughout the capacitor, so it can be come out of an integration and it will total become an area A. I is equals to sigma is conductivity, the reverse is the resistivity 1 by rho. And the electric field can be given as, in the case of electric field will be equals to, in case of capacitor, the electric field inside the capacitor can be given as Q by A epsilon naught. Q by A is a sigma, that is Q by A is a sigma by epsilon naught, that can be written as, so Q by A epsilon naught into A. So this will be the actually maximum current. Although with respect to time the current is varying, so we should have a variable relation, but we are using the maximum current. So this will be equals to Q by rho epsilon naught. If the charge is constant, means somehow if I will supply a constant charge, let's take the certain amount of charge is leaked also, but we will supply the remaining charge by a battery, and I'm assuming that situation. In that case, what will happen? So it's an equilibrium positions we are dealing with. So in that case, the total leakage or the current that will be flowing through a capacitor will be equal to this. है ना? Although we know in reality if this battery is removed, although in this case the battery is already connected, so what happens is a small amount of leakage of charge from the capacitor will be fulfilled by the battery, so we can say that the total charge remains constant. But if the capacitor is charged outside and the battery is removed, if the battery is removed, so it is not mentioned here, if the battery is removed, in that case the charge will gradually decreases, and the charge will decreases as exponentially with the time, then the result will be same, only the charge variation you have to apply with respect to exponentially with respect to time. But here I have to deal with only I, because the charge through the capacitor is not varying, so I will be equals to Q by rho epsilon naught. Q is a charge, so charge is equals to CV for a capacitor. So 2 pico means 10 raised to the power minus 9. Q is equals to 10 raised to the power, pico means 10 to the power minus 12 into voltage is 40, and the resistivity for this material is given as 200 ohm meter, and it's all in SI, so no problem. Here you have to use epsilon when this is filled with air, but we are taking a dielectric, so there will be K also, the dielectric constant, and the dielectric constant here will be given you as 50, 50 dielectric constant into and the value for epsilon is 8.85 into 10 raised to the power minus 12. So luckily 10 raised to the power minus 5, 12 cancel, 0 cancel, 2 100 milli, so this will become 4 by 8 5 jo 40, so it will be more than 40, so roughly 5, I can say that 8.85 into 5, and we can solve this, and this will become 100, and this will be a degree raised, so this will take it's become milli, and this will be like 5 into 0.885. So 4 divided by 0.885. So roughly they will be like 4 itself. So we are getting an answer of 1 milli. We are getting an answer of 1 milli or a bit less than 1 milliampere. That will be a point 0.9 milliampere will be the better option. Well, this will be 4 and this will be roughly 4, a bit higher than 4. So this will become a roughly equals to just less than 1 milliampere, a bit higher than 4. So this will give you 0.9 milliampere should be the correct answer for this question. The next question. By doping silicon semiconductor with pentavalent impurities, doping silicon semiconductor with pentavalent impurities, the electron density increases. It's true. Because if you will add pentavalent impurities, pentavalent means there are 5 electrons, and for silicon there will be requirement of 4 electrons to complete all the covalent bonds. So let's take silicon. So there will be 4 electrons and 4 electrons further are required to complete the covalent structure, and you are giving a pentavalent impurity. So 4 will be used and further 5 will be an extra, and that will behave like an extra free electron. So electron density will indirectly increases. So the first statement is correct. The second statement says that the n-type semiconductor has net charge. The second statement is false. The second statement is false because the material makes a composition in such a manner that although n-type semiconductors has more n-type semiconductor has more electron density than the holes density. It doesn't mean that it is electrically charged. It only means that the to maintain electrical neutrality, the material itself will adjust and it will make a composition like this way that it will remain neutral as such. So all type of semiconductor, whether it's a p-type or n-type or a diode also, it's a neutral substance. Next. So thank you for watching this. Please subscribe our channel, YouTube channel, Sapiens Education, as well as you can visit us at Meta as well as Instagram, sapienseducation.com. Thank you very much. I hope for your well-being. Have a nice day. Take care. Keep smiling. Bye.